So this video is going to be on a quick review of the Pythagorean theorem, just so that we can make sure that we re-get that information because we're going to be using quite a bit in this last little section we have here for school. So let's get right into it. So remember, right triangles, the Pythagorean theorem are very key concepts to most of geometry. Most shapes can be, approximated or at least kind of guesstimated by using right triangles as sort of the building blocks, so to speak. So right triangles have a very important sort of key idea or key concept in geometry. So let's take a look at what we're going to be doing here. So Pythagorean theorem, very simple theorem, simply states, most people know it as a squared plus b squared equals c squared. In word form, it means in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. Which basically means if you have a right triangle, remember the hypotenuse is the angle, or sorry, not the angle, but the side across the right angle. So if here's my right angle, I draw an arrow, that's my hypotenuse. So C is always my hypotenuse, or hypo as I'll abbreviate it. So A and B are called the legs, and it really doesn't matter which one you call A or B. Like I could put B up here, and I can put A down here, and it'd be the same thing. C is the important one. C is always the hypotenuse, and it has to always be across the right angle. So use that little arrow trick we have here if that's going to help you. So how do we use this to solve right triangles? Well, there's, again, sort of the basics, and we have more complicated problems. So we'll start with the basic problems here first. So the basic problems, if we have this, let's take a look at this one first. I'm a little scatterbrained, I don't know why here, so sorry about that. We have our A and our B. So our 9 and our 12 are A and our B, and we're missing our C. Now again, I put an X here, but if you want to erase this X and put a C, that way we're using the same variable wording each time, you can go ahead and do that. But let's go ahead and write our theorem here. So A squared plus B squared equals C squared. Well, I know A is 9, I know B is 12, and I know C is X. So you just go down the gambit here and solve it like an Algebra 1 problem. 9 squared is 81, 12 squared is 144, x squared is x squared, because we don't know what that is. We're going to add 81 and 144, so 81 plus 144, and we get 225. 225 equals x squared, and then we square root and square root, and we get 15. I don't need to do a calculator for that one. So we get that x is equal to 15. And that's it. So for that problem, we'd be done. We found what x is, we found what the hypotenuse is. And again, the way you can check yourself is that the hypotenuse should always be the longest side. That's why it's called a special name as the hypotenuse rather than just a side. So the hypotenuse should always be the longest side, and 15 is definitely longer than 9 and 12, so we're good there. This one here, same idea, except now we're missing a leg piece. So we have A and we have C, but we're missing a B here. We set up the same way. 10 squared plus x squared equals 26 squared. And we just run the gambit again. So again, hopefully this is sounding familiar because we've been using right triangles throughout a lot in our geometry class. So hopefully we catch the drift here, right? So 10 squared plus x squared equals 67. Now, or not, well, 100, because that's what 10 squared is. But anyway, so to solve for x squared here, instead of adding, we're going to need to subtract, right? So we're going to subtract 100, and we get x squared is equal to 576. And then we square root and square root. So we're going to square root 576. And we get x is 24. Which again makes sense, equals 24, because this should be smaller than the hypotenuse, and 24 is indeed smaller than the hypotenuse, so it's a decent answer. Doesn't mean it's always going to be correct. You could get an answer that's smaller than a hypotenuse and wrong, but that usually means you were on the right track if you get something that's smaller than a hypotenuse when you're solving for a leg. Now, if you notice here, these problems are done very similarly, except that there's one different step in the middle, right? So here we had to square both numbers first, then we added the numbers together, and then we square rooted to get our final answer. Here, we squared both numbers first, then we subtracted them from each other, and then we square rooted to get our final answer. So here it was square add root, here it was square subtract root. So again, very similar problems to each other, just a slight difference in that middle step. Now, the converse, when you talk about the converse of something in geometry, we did this when we did proofs. The converse is basically the reverse of a theorem. So the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. The converse says if a squared plus b squared equals c squared, then you have a right triangle. And basically what we use this is to check to see if three sides make a right triangle. Not if they make a triangle, but if they make a specifically right triangle. And the way we do that is we just plug them into this formula and see if it works out. So here we have 15, 36, and 39. So the main thing is to get your c right, correct? And your c should always be the largest number. So in this case, 39 is my c. So I'm going to check, does 15 squared plus 36 squared equal 39 squared? If it does, then we have a right triangle. If it doesn't, then we don't. So if we check this here, 15 squared plus 36 squared gives me 1521. 1521. And 39 squared, so 39 squared gives me 1521. So this is a true statement. 1521 does equal 1521. So we'd say, yes, this forms a right triangle. These three sides, when put in the triangle formation, will make you a right triangle. What about this one here? So it'd be 6 squared plus 8 squared equals 12 squared. 6 squared I know is 36. 8 squared I know is 64. 12 squared is 144. We add these together. We get 100 is equal to 144. And that most certainly is not true. So this would be no. These do not form a right triangle. Okay? And again, I knew 12 was my C because 12 was the biggest number. In this set here, you have 2 and 2, which again are obviously the same amount. So 10 is still going to be your C, and then 2 and 2 would be your A and your B. So 2 squared plus 2 squared equals 10 squared. We get 4 plus 4 equals 100, which definitely is not going to work out. 8 equals 100, that's way too small. So this would also be a no. Also, this would not even form a triangle because if I have a length of 2 there, and I have a length of 2 there, I'm not going to be able to fit a piece of 10 in between them. It's going to be like this, and that'd be my 10 piece. So it wouldn't even form a triangle, let alone a right triangle. But again, that's a little outside the scope of the content here, but just a little addendum. Anyway, that's how you use the converse of the right triangle theorem, or the converse of the Pythagorean theorem, to figure out if shapes would form a right triangle if you put them in that fashion. And then lastly here, sometimes you need to use the Pythagorean theorem back to back. So we just did it once in each problem here so far, but if you have a problem like this, you can use the Pythagorean theorem multiple times in a row to help you get to a missing piece. And it's actually very helpful in certain problems if you have a lot of right angles, because you can use it and make a lot of right triangles and kind of work your way towards the piece that you need. So for instance, I need this piece over here. And I notice that this big thing is a right triangle, which is great, but I don't know how long this side is. This is 4 plus some number. I don't know. We'll call this y here. This is 4 plus y. I don't know how big this side here is. So I'm going to solve for this top right triangle first, get what the y is, and then use that to help me figure out this big triangle. So for this top triangle, 13 would be my c, because that's across the right angle. So it'd be 5 squared plus y squared, because I don't know what that side is. I don't know how big this side right here is equal to 13 squared. 5 squared is 25 plus y squared equals 13 squared is 169. Quick maths there, right? Minus 25 minus 25. We get y squared is equal to 144. And then we root, and we get y is equal to 12. So I now know that y is equal to 12, which is great, but I want to know what x is. So what I'm going to have to do is, now that I know that this piece right here is 12, I know that this entire piece is 16. So now I can use that to solve for this right triangle here. Now in this case, I need to find my hypotenuse. I'm missing my c value. So I'm going to have to write out as 16 squared plus 15 squared is equal to x squared. So notice that even though you're using the Pythagorean theorem back to back, you're not necessarily always using it in the same way. So 16 squared is, let me just do it in my head here, wink wink, 256, plus 15 squared is 225. I do know that one. 225. My handwriting's awful today. Well, awful, or it's probably not the word, but whatever. So that there, and we add these together. So 256 plus 225 equals 481 is equal to x squared, and then we root, and we get whatever the square root of 481 is. So root 481, and we get 21 point, we'll say 93. 21.93. So again, some problems you have to use the Pythagorean theorem back to back, and you might have to incorporate your answer in the previous work to your answer in your current situation. So again, breaking stuff down to right triangles is a very key concept in a lot of geometry theorems and problems. So don't be afraid to look for those right angles and see where you can make the right triangles. Just make sure that you can at least know about two of the three sides. Because again, the Pythagorean theorem works well as long as you know two of the three. So make sure you know those before you step into it there. So that's it for this video. Again, hopefully it was a pretty short one here. But that's, again, just a quick review on Pythagorean theorem, because next time we're going to get into SOHCAHTOA, or review SOHCAHTOA, which, again, does a lot with the right triangle and trigonometry and all that. So just want to make sure we have this under our belt, and we're good to go there. So hopefully you enjoyed the video. Have a good day.